So let's jump over here to Windows 10 for a minute and continue working on our app. And the reason I want to come over to Windows is I want to explore this performance problem. And the tooling on Windows is super good for understanding the performance characteristics of individual applications rather than system-wide. So we're going to change the problem space a little bit. We have been previously searching this books folder. And if you go look at the properties, you'll see that's about 5 megs of text. That's a serious quantity of text, and it's blasting through it. So that's already impressive. But let's look at a different amount. Here we have some more books, but now we have 2.27 gigabytes of TXT files. That is a ridiculous amount of text files. You'll see that if we try to search that content, well, the app actually does surprisingly well. It really does go through it and find the results and so on. But if we leverage this concept of generator methods and related things that we'll build on in other applications farther down the line, we can actually do amazingly better. Okay, so just to make sure everything's working on Windows, let me just search this same stuff here. Okay, so we want to search C Users Infinity Desktop Books, and let's search for Incredible. Excellent. So it looks like we found some. Inverseness, 2 from Incredible Age, right? Ulysses, A Doll's House. Not too many results there, but you can see it's working. Fantastic. Now, I happen to know from trying this earlier that we need to change this output here. In fact, if we print out all of this, it's going to be so much output when we go through the 2 gigs of files that it actually causes problems. A significant part of the performance is literally that print right there. So instead of doing this, we're just going to go and do a count. So we'll say match count. Now, right now, this is a list, and I could just do len of list and just print that out. But it's going to turn out that when this becomes a generator, len of generator doesn't mean the same thing. So let me just independently keep track of the count. And we'll just say something like this. And let's put our little comma separator, and we'll do dot format and match count. So let's run this one more time. Okay, same place. Let's search for funny. And apparently we found 33 matches of the word funny in the 5 megabytes of text. That was really quick. That's awesome, right? But to just sort of push a little bit harder on the performance perspective, let's search the 2.27 gigs of text. And we're going to search for something, maybe question mark. So let me introduce you to Process Explorer. So Process Explorer is kind of like Task Manager, Activity Monitor from OS X, but it gets a ton of information, both visually as well as through things like performance counters on Windows to tell you what is going on with the apps. And it lets us, here's our Python app that is waiting for us to hit go. All right, here our app goes. Look, here's our sort of operating memory down here, and it's dropping into the distance. So it turns out that searching for question marks in this file, there are a ton of them. So we're building them up into our list as we're recursively going through these files on disk. You can see it's pretty computational heavy, pretty IO intense, but really the memory is just growing and growing. You'll see that when we get to talking about generators, that maybe this is not the way this app has to behave, right? We can actually incorporate very minor changes into our app and get dramatically better performance, at least from a memory perspective. All right, our process has finished, and we found 2.7 million question marks in those files. And look at the memory. This is not the most amazing outcome that we could have had. It turns out it took almost 400 megabytes the way we've implemented our algorithm. And depending on how we hold the data or the size of the data, it could be even worse.